What is the basic reproduction number, and what is its relevance to COVID? Since the beginning of the pandemic, we have heard a lot about the basic reproduction number, also called the initial reproduction number, or more famously R0. R0 is the expected number of cases directly generated by one case in a population where all individuals are susceptible to infection. For example, if patient 0 here directly infects 2 people in the population with this new virus, then the R0 of this virus is 2. R0 has been misinterpreted many times in the past. Let's have a look at what R0 is and what it is not. It is not a biological constant for a pathogen. It is not a rate over time. It is not a measure of disease severity. It cannot be modified through vaccination. R0 is rarely measured and typically estimated using mathematical models fitted to data. It is a complicated metric. I will come back to all these aspects later in the video, but now let's take a look at how we can estimate R0. The estimations of R0 values are often calculated as a function of 3 primary parameters: the length of time an infected person is contagious, the likelihood of infection per contact between a susceptible person and an infectious person, the contact rate between people. The 2 first parameters are biological constants, but the contact rate can vary, and therefore R0 is not a biological constant for a pathogen. The contact rate, and therefore R0, may depend on population density, for example. We expect that someone living in London typically interacts with more people in a day than someone in a rural area. Therefore, R0 is a function of human social behavior and organization, as well as of the biological characteristics of a particular pathogen. That means that, for a same virus, it can vary depending on where it is estimated. For example, for the original strain of COVID-19, Shaw and Kennedy collected the estimations of R0 from different regions, and we can see here that it ranges from 2 to 4. R0 has other limitations. By its definition, it reports a number of secondary cases in a completely vulnerable population. It means that it concerns pathogens that are introduced in a population that has not been exposed previously and that has not been vaccinated. It therefore cannot be affected by vaccination and cannot be used to characterize the infectiousness of a disease in an everyday basis. Also, R0 indicates the new infections generated throughout the lifetime of a primary infection, not over calendar time. It does not indicate whether new cases will occur within 24 hours after the initial case or months later. In this video, we have seen what R0 is and what are its limitations. We have seen that several different R0 values have been estimated for the COVID-19 outbreak. However, it is difficult to estimate R0 for the subsequent variants since, when they occurred, the population already had a level of immunity, either due to previous exposure or vaccination. Despite the limitations mentioned previously, R0 is still a useful metric and can indicate if the infection will continue for R0 greater than 1 or if the infection will end for R0 smaller than 1. It is therefore a tool to assess the potential size of an outbreak. The links to the articles used for this video are in the video description below. In the next video, I will talk about the effective reproduction number, a useful metric to measure infectiousness during a pandemic.